Why do fractal patterns show infinite detail? Imagine zooming into a tiny part of a pattern and finding more complexity than you saw before. That's what makes fractal patterns so fascinating. They seem to go on forever. When you look at a fractal, no matter how much you zoom in, new shapes and details keep appearing. This endless complexity comes from a process called recursion, where a simple rule is repeated over and over again at smaller scales. Each step creates a new version of the pattern, which looks similar to the previous one. This self-similarity means the pattern stays consistent no matter how close you get. The reason they show infinite detail is because each repetition adds more intricacy. Think of a snowflake or a fern leaf. When you examine them closely, you see smaller versions of the whole shape. These natural fractals form because of growth processes that follow recursive rules. For example, trees grow branches that look like miniature trees, and coastlines have jagged edges that seem to continue forever when you zoom in. Mathematically, fractals are built using equations that are applied repeatedly. Some, like the Mandelbrot set, come from complex number formulas that are calculated again and again. Others, like the Koch curve, are made by replacing a straight line with a more detailed shape repeatedly. Each step increases the detail and length of the pattern, but the overall shape stays consistent. This repetition creates a boundary that is infinitely detailed, yet never smooth or simple. Fractals also have a special property called non-integer dimensions, which measure how complex they are. Unlike a straight line that has a dimension of 1 or a flat surface with a dimension of 2, fractals exist somewhere in between. This means they fill space in a unique way, creating jagged edges and intricate shapes that seem to go on forever. In nature, you can find fractal patterns everywhere. The branching of trees, the shape of mountain ranges, the outline of coastlines, and even the structure of blood vessels all follow recursive rules. These natural fractals show infinite detail because their growth mimics the mathematical processes that generate fractals. This connection helps us understand how complex natural forms develop and why they look so detailed at every scale. Understanding why fractal patterns show infinite detail helps us see how numbers and natural phenomena are connected. It explains why some shapes seem to have endless complexity, and how simple rules can create the intricate beauty we observe in the world around us. Whether in math or nature, fractals reveal a universe full of repeating patterns that stretch beyond what we can see at first glance.